Hi everyone, welcome back to Coding Fab. Today we're diving into one of the most popular web frameworks for Python, Flask. We'll start by exploring what Flask is and why it's perfect for building backend applications. Then we'll walk through setting up your first Flask project, understanding its basic structure, and gradually move into templates, forms, database connections, and error handling. Finally, we will demonstrate the development of a simple web application that applies what we have learned in this lesson. Whether you're just getting started with web development or looking to strengthen your backend skills, this lesson will guide you step by step. All right, let's get started. 1. What is Flask? Flask is a lightweight and simple web framework for Python. It helps you build web applications quickly and easily. And it runs on the server side. It's responsible for the backend, while front-end technologies like HTML, CSS, and JavaScript handle the user interface. Let's imagine building a website. Think about your favorite websites, like an online store or a blog. Behind every website, there are a lot of things to do, like create pages, handle buttons and forms, connect to a database, send and receive information, and more. Without Flask, you would have to build everything manually. But Flask can make it super simple. It's like a toolbox with a full set of ready-to-use tools. So you don't need to build everything from scratch. Flask saves you tons of time. 2. Setup. First of all, you need to set up Flask by following these steps. It's a bit long, but not so difficult. Let's go through together step by step. Step 1. Install Visual Studio Code. There are several options for the development environment for Flask, such as Visual Studio Code, PyCharm, and more. In this course, we'll use VS Code since it has great features such as lightweight, fast, tons of extensions, great Python and Flask support, and more. Okay, let's install Visual Studio Code. Go to the VS Code website, download and install it for your operating system. After installing, open Visual Studio Code. Now your VS Code is ready. Step 2. Install Python. Flask runs on Python, so you need Python on your computer first. To check if Python is installed, open your terminal for Mac and Linux or Command Prompt for Windows. And type this. If it shows Python version, you are fine. If not, you need to download Python first. Go to the Python website and download the latest version. Install it by following the instructions for your operating system. You will be asked to agree to the terms and conditions, but just confirm and click Next. And enter your password. It takes time. Now it's installed. You can close the windows. Then open the terminal or command prompt and check Python if it is installed correctly by running the Python version command again. Here you can see the Python version. So now it's ready. Step 3. Install Python extension in VS Code. Let's open VS Code. Click the extensions icon on the left sidebar, looks like 4 squares. Search for Python. Install the official Python extension by Microsoft. This extension helps you run Python smoothly in VS Code. Step 4. Create a new project folder. Make a new folder for your Flask project. Folder name is like Flask project. You can create it anywhere, like your desktop. By the way, in Python, snake case is mainly used. Step 5. Create a virtual environment. This is optional but recommended. A virtual environment is like a mini Python installation just for your project. It keeps your project's packages separate from other projects. Okay, let's create a virtual environment. Open your VS Code and project folder. Then open a new terminal. Run this code in your terminal. A new virtual environment is created here. Next, activate it with this code. You should see something like this appear before your terminal line. So now you're working inside the virtual environment. Step 6, install Flask. Inside your virtual environment, install Flask by typing this. Flask will be downloaded and installed. You can double check by typing this. It will show Flask's version, installation path, and more. Step 7, create your first Flask app. In your Flask project folder, create a file named app.py. Then write this simple code inside the file. We'll go into more detail later, so for now let's ignore the details and just write the code. Step 8, run your Flask app. Largely, there are two ways to run your Python file. The one is click the run button at the top right or use shortcut key shown here. Another one is in the terminal, type this. Make sure you are in the project folder. This code means run the Python script named app.py using the Python interpreter. When you run a Python file, always need the Python command first, then file name. After running the code, you will see this URL in your terminal. Open your browser and go to the URL. Or you can directly go to the page by clicking the URL with Control or Command key. Then you will see Hello World. Great. You just set up Flask and ran your first app. 3. Basic structure. In this section, we'll go through the structure of a Flask application. First, a minimum Flask app to start a Flask server, then a more typical application that consists of HTML, CSS, JavaScript, and more. First, minimum Flask app. Largely, there are 4 steps to create the smallest Flask app. 1. Import the Flask toolkit. 2. Create the app object. 3. Define root and function. 4. Start the Flask server. In code, it's written like this. Let's walk through it step by step. This first line imports the Flask class from the Flask package. Without importing Flask, you can't use any Flask features. This line creates a new Flask app object from Flask class. The name part tells Flask where to find your files. So this app will be the main thing that runs your website. Next, this is called a root decorator. It connects a URL path to a Python function, the / which means homepage. Whenever someone visits this page, Flask will call the home function. Inside the home function, the return part sends back a response to the browser. It returns the text "Hello World" so that the user sees it on their screen. This line checks if this Python file is being run directly. If yes, it runs the code inside, starts the Flask app. It's a standard Python trick to control how the program starts. This starts the Flask server. The server listens for requests, like when someone opens a web page. Debug true means if you change your code, Flask automatically reloads. It will also show helpful error messages if something goes wrong. So this is super useful. 2. Common Flask app. At first, your app is small. But as your project grows bigger with any pages, forms, and databases, it gets messy if everything is in one file. So we organize into folders and files to keep things clean and easy to manage. In Python, we have to do that manually. The basic structure looked like this. First, prepare a project folder. In this case, it's called Flask project. Then create a main Python file inside the project. Next, prepare static and templates folders. Static folder for static files such as CSS, JavaScript, and images. Templates folder for HTML files for web pages. You can create and expand HTML files for each web page. By following this structure, you can make your code simple and can handle bigger projects. 4. HTTP methods. What are HTTP methods? When you visit a website or click a button, your browser sends a request to the server. There are different types of requests called methods. The two most common methods are get, ask for information such as opening a web page. Post, send new information to the server such as submitting a form. Let's check the code. First, get. In Flask, actually the default is get. If you don't say anything, a route uses get. So when you visit this page, it's automatically a get request. You can omit writing methods. When you want to receive form data like a username, password, you need to accept post. You add methods post in your route. Of course, you can write get method as well like this. This login function means if you visit login page and the method is not post, it shows a form because the default setting is get request. If you fill in the form and submit as a post, Flask handled the form submission. To make the example simple, the return parts are omitted. 5. Templates with Jinja 2. 1. What is Jinja 2? Jinja 2 is the template engine that Flask uses. It lets you write HTML pages with special placeholders like double curly braces. These placeholders are filled with real data when the page is shown. So you can mix Python-like code such as variables, loops, if statements inside your HTML using placeholders. 2. Simple example. Let's say you want to insert a variable inside a HTML file. Jinja 2 make it super easy. Let's go through step by step. First, create home HTML file inside the templates folder. Then write this code. This is the basic HTML code. The only difference is the variable called name with double curly braces. Flask will replace it with a real value. Next, update the main Python file. You import two things from Flask. Flask class to create the web app, and render template to load and display HTML files from the templates folder. Then use it in the home route. Instead of sending back plain text, you are rendering an HTML file called home HTML. You also send data. The value Tom is passed into the template as name. Inside home HTML, you can use the name variable to show this value on the page. If you run the code, you will see the name of Tom. These are the methods of Jinja 2. First, variables. As we have seen in the previous page, you can insert the data into HTML file using double curly braces. Next, expressions. Jinja 2 allows you a small calculations or operations inside the double curly braces, such as add, subtract, multiply, divide, or even join text directly in your templates. Next, if statements. The curly braces with percents are special tags for logic, like if statements and for loop. If the condition is true, the content will be shown. If it's false, the content will be skipped. For example, you can write like this. This message will be shown only if the isLoggedIn variable is true. If it's false, nothing will be shown. Next, if-else statements. You can add other statement by using else. For example, let's say you want to check a user's role. First, check if the user role is admin. If it's true, it shows welcome admin. Otherwise, it shows welcome user. Next, for loop. For loop, also use curly braces with percentages, since this is a logic operation. The for loop ends with M4. Inside the for loop, it repeats the content for each item in the list. So you need to give it a list. For example, let's say you want to show the list of fruits on your web page. You can use for loop like this. But first, sends the list of the fruits from the main Python file to the template. It looks like this, passing fruits list. Then Jinja2 loops through the list and creates one list for each fruit. The web page will show apple, banana, and cherry. If you want to show the index number, you can use loop index like this. Next, set a variable. The curly braces with percents are used for it. The set lets you create a new variable inside your template. You can then use that variable anywhere later in the same template. For example, let's say you want to create a new variable called greeting. Here it's created with the value hello world. Then you can call the variable anytime like this. Next, include template. It tells Flask to insert another HTML. It's like copying and pasting another file's content into your current page automatically. It's often used for reusable parts such as navigation bars, footers, sidebars, and more to avoid repeating the same code in many files. Also, to make your templates easier to update. For example, let's say you are using the navigation bar on multiple pages. By using include, you can write the code like this. First, prepare the navbar HTML file. Now in your home HTML file, you can include it like this. It inserts the content of the navbar exactly where the include is. The user sees a full web page with the navigation bar and the home page content. Other pages as well. You can use the include in the other pages as well. If you want to make some changes to the navigation bar, you just need to change the navbar HTML file. Then the changes will be applied to the other files that use include. So it helps to avoid repeating the same code in many files. Also, make your templates easier to update. Just update one file. Next, extending a base template. This is the basic syntax. Extends tells Flask, this page is based on another file. In this case, it's base HTML file. The block defines parts that can be filled or replaced by each page. Then you can make many pages that share the same content, such as header, footer, and also styles, only changing the block part. For example, let's say you want to create a website that includes a home page and an about page, and want to use the same header and footer. Only want to change the head title and body content. First, let's prepare a base HTML file, which is the main layout. In the base HTML file, we have two blocks, block title for the page title, and block content for the main content. Next, create a home HTML file. It extends base HTML file, also includes the title block, and content block with specific text. The title is home title. The content is home page content. Let's check the result of the home page. Flask uses the base layout, which has a header and a footer, but fills in the title and content blocks from the home HTML. If you want to use the same format and only want to change the title and content in other pages, you can easily do that. This about page only changes the title and content. So the benefit of using extends is to save time, no need to repeat the same structure, to keep layouts consistent across your site, to update easily. If you update the base HTML, all pages are updated automatically. This is perfect for websites with many pages and projects that need the same header and footer everywhere. Next, filters. A pipe symbol is used to apply a filter to a variable. A filter modifies or processes the variable before displaying it. These are the commonly used filters. The lower filter changes all letters in a string to lowercase. The upper filter turns all letters into uppercase. The title filter capitalizes the first letter of each word. The length filter returns the number of items in a list or the number of characters in a string. The replace filter substitutes one character or word for another, such as replacing A with B in a string. Next, comments. The curly braces with hash marks are used to write a comment in Jinja 2. Anything inside it will be ignored by Flask and not shown on the web page. It's just a note for developers. 6. Static files. There are two key points when it comes to handling static files. First, prepare a static folder. Flask uses this special folder to store CSS images in JavaScript. Next, the URL for function. It connects an HTML file to static files. Let's say you have a home HTML file in the template folder and want to link it to static files such as CSS, JavaScript, and the image file in the static folder. In the home HTML file, you can write something like this. Use proper HTML tags for each, such as link tag for CSS, MG tag for image, and script for JavaScript, respectively, and put the URL for function in the link part. Then write proper file names respectively. If you have more image files and store them in a folder, you need to change the file name path like this. Seven, Flask forms. A form is how users send information to your website. There are various types of forms, such as login forms, contact forms, sign-up forms, and feedback forms. These forms collect user input and send it to Flask to process it. In Flask, largely, there are two ways to handle forms. Use regular HTML forms and Flask WT forms. Let's walk through each of them step by step. 1. Regular HTML forms. The basic HTML form looks like this. This form collects a text input, username, sends the data to the server using post method, then sends it to the URL path, submit. In your Python code, prepare the route for submission like this. When you submit the form, Flask receives the data at the submit path. The request form username grabs the value entered by the user. Flask then returns a greeting with that name. Important points are: the action URL matches the route URL. The root method is post. The request form value matches the input name. Two, WT forms. WT forms is a Python library that helps you build forms in a cleaner, safer, and more powerful way. Instead of writing all the form HTML yourself, you can create forms in Python code and automatically generate HTML. WT forms also validates the user's input automatically, like checking if the field is empty. Let's set up WT forms. There are 4 steps. Let's walk through step by step. 1. Install Flask WTF. You need to install the Flask WTF extension, which connects WT forms with Flask. Let's run this command in your terminal. 2. Create a form class. Let's create a new Python file called forms.py. In your file, write like this. First, import Flask form from the Flask WTF package. Flask form is the base class that your form classes must inherit from. It connects WT forms to Flask and handles important things like security. Then you import 2 types of form fields. String field for text input where users type something. Submit field for the submit button to send the form. Then you import a validator called data required. This ensures that the field cannot be left empty. The user must type something before submitting. If the user submits an empty form, it will show an error instead of accepting it. Next, create a new form class called nameForm. It inherits from Flask form, meaning it becomes a Flask-friendly form. Inside this class, you define all the fields your form needs. First, define a field called username. It's a string field, meaning users can type text into it. Your name is the label that appears next to the input box. The validator's data required means the field must be filled in. If the user leaves it blank, Flask will automatically show an error message. Finally, define a submit button called submit. The submit is the text that appears on the button. When users click this button, the form is sent to the server. 3. Use the form in your root. Open your main Python file and import basic Flask functions. Also, import the nameForm class from the form's Python file. Nameform is the form you created earlier using Flask WTF. Next, set a secret key to enable secure form handling. Needed for CSRF protection, prevents hackers from tricking your forms. You should use a random secret key in real projects, not a simple string. Then define a route for the home page. Allow both get requests when you open the page and post requests when you submit the form. In the home function, create an instance of the nameForm. If statement checks, has the form been submitted? Is the form valid? No missing fields, passes all validators? If yes, continue inside this block. If no, show the empty form again. Form username data, get the value the user typed into the username field. The data holds the actual user input. If the form is successfully submitted and valid, show a simple message greeting the user with their name. If the form is not submitted yet, or if it's invalid, show the home HTML page and pass the form to it. 4. Create a WT Forms enabled HTML. Let's create a home HTML file and write this. This part is the same as the regular HTML form method we learned earlier. This tells the browser to send form data to the server using the post method and submit it to the home route. This inserts a CSRF token hidden input, helps protect against cross-site request forgery attacks, so it's required when using Flask WTF. This displays the label for the username field. Form username displays the actual input field for the username. Size 30 means the input box will be 30 characters wide. Form submit displays the submit button. Now you have the HTML file with WT forms, forms model, and the main Python file that handles form requests. Let's run the main Python file and see how it works. This is the landing page. It shows a simple form to get a username. Let's enter a username and click submit. Then you'll see hello and your name. If you submit without any text, you'll see an error message since we set a validation data required. It's so easy and useful. Flask WT Forms provides various types of options for fields and validators. Here's the common field types and validators. The template is in the bottom right, so try changing the field type and validators and see how they work. When it comes to the form submission, redirect and URL4 are often used. Redirect tells the browser to go to a different URL. URL4 generates the URL for a given Flask route by function name. Here is the updated code from the previous code using a redirect and URL4. The differences are importing redirect and URL4. Then define another route that accepts a dynamic part username. Whatever name the user entered will be captured here. Inside the route, define the greet function that receives the username. Then show the greet HTML page by passing the username to display a personalized greeting. In the home root, added redirect and URL4 to redirect the user to the greet page. Pass the username as part of the URL. This is a good practice for the post, redirect, and get pattern. This pattern can be used for form submission, login, logout, and successful action. This is the quick summary of the render template, redirect, and URL4. Eight, Flask with databases. 1. Database and SQLite. A database stores your app's data permanently. The data is like user info, form submissions, blog posts, and so on. Without a database, your data disappears when the app stops running. There are many different types of databases, such as SQLite, MySQL, PostgreSQL, and more. In this lesson, we will use SQLite. Because SQLite is included in Python, no extra software is needed. So SQLite is the best starting point for learning Flask and databases. It's simple, fast, and needs no complicated setup. On the other hand, Flask uses SQL Alchemy, a powerful library for connecting to databases. Let's learn about it next. 2. Flask SQL Alchemy. Flask SQL Alchemy is a powerful Python library for databases. You can create tables, add data, query data, and delete data using Python classes, no complicated SQL commands needed. Here are the basic steps to use SQL Alchemy. First, install Flask SQL Alchemy. In your terminal or command prompt, type this. This installs the library so you can import and use it in your app. 2. Creating a model. What is a model? It's like a blueprint to create a database table. Each attribute in the model, like ID, username, email, becomes a column in the database table. SQL Alchemy converts this Python class into real database code behind the scenes. Let's say you want to create a user table. First, create a new Python file named models. In that file, import the SQL Alchemy extension for Flask. SQL Alchemy helps you manage databases using Python classes instead of writing SQL directly. Then creates a database object DB that you can use to define models and interact with your database, such as add, query, update, delete. This DB will be linked to your Flask app later. Next, create a class called user. It inherits from DB model, which tells SQL Alchemy this is a database table. The table name will be automatically set as user in lowercase. Next, the user table has 3 columns. First, ID. This will be stored as integer numbers. Also, this column is the primary key, meaning it uniquely identifies each row. It auto-increments, so every user will have a unique ID. Next, username. This becomes another column and can be stored as text up to 20 characters. Unique is true means no 2 users can have the same username. Nullable is false means the user must enter a username, cannot be empty. So it ensures that each username is unique and required. Next, email. It can store text up to 120 characters. Unique is true. Nullable is false. So it protects against duplicate or missing emails. Now you have a real database table defined using simple Python code. Later, Flask's Alchemy will automatically create this table in your database when you run. 3. Connect database to app. Open your main Python file and write this code. First, import Flask so you can create the web application, and also import the DB object from the model's Python file. This part means use SQLite and save the database file as site.db in your project folder. Then initializes the database with the Flask app. This connects the DB object from the model's Python file to the app instance. If you want to write everything together in one main Python file, which means make the app and models file together, you can connect the app and database with this code instead of using init app. But considering that the project size will increase in the future and to make the code easier to read, it would be better to have separate main and model files. Now your Flask application and the model we defined are connected. Next, let's generate a database file. 4. Generate a database. Now your Flask application and database model are connected. Now let's generate a database from them. To make it simple, let's create a new Python file to generate a database. Let's name it createDB. Inside the file, let's import the app and DB objects. This sets up the Flask app context to access Flask app and the database. Think of it as turning on Flask so it knows what database and app it's connected to. DB creates all tables based on your models. Once you run this file successfully, you'll see the message, database created successfully in your terminal. Also, you can see a new folder named instance and a database in it. Now your database is ready. Five, CRUD operations. First, create. Let's create a new Python file named adduser to understand clearly. Inside the file, first, import the app and the DB object, and the user class from app and the model's Python file. This sets up the app context so database operations can run. The user class creates a new user object with the username and email from the model. DB session adduser prepares the user to be saved. Then DB session commit actually writes the user to the site DB file. Once you run this file or run this code in your terminal or command prompt, it will insert a new row into the user table in site DB. Also, you'll see the message user added successfully in your terminal. You can view the contents of the site DB in table format by downloading the DB browser for SQLite and opening the site DB file. Next, read. Let's create a new Python file named queryUsers. First, import the app and the user class. Then activates the Flask application context. Then you can access the Flask application. This query all retrieves all records from the user table. It returns a list of user objects. So you can use a for loop to grab each user in the list. For now, it shows only one user because we added only one user. Next, update. Let's create a new Python file named updateUser. Let's say you want to update the email of the user whose username is user1. Inside the file, first import the app DB and the user class. Next, activates the Flask application context. This searches the user table for the first user with the username user1AE. If found, it stores the user object in the user variable. If not found, the user will be none. If the user exists, update the user's email address in the Python object, then saves the change to the database with commit. After running the code, you'll see a message, user1, email updated successfully. Just to be sure, try opening the file with DB browser for SQLite and check the update. Next, delete. Let's create a new Python file named deleteUser. Let's say you want to delete the user with the username user1 from the database. Inside the file, import the app, DB, and the user class and activates the Flask application context, then ready to access the app in the database. This part finds the user you want to delete. DB session delete marks the user for deletion. DB session commit permanently removes the user from the database. After running the code, you'll see the success message and the user is not in the table anymore. This is the quick summary of CRUD operations. In this table, two more useful methods are added. The first one is queryGet. It finds a record by primary key. It's an ID number. Another one is query filter with like condition. It helps search for partial matches. What is like method? The like method is used in queries to search for partial matches in string fields, like email, name, and so on. It uses wildcards like % and underscore to build patterns. % means matches 0 or more characters. Underscore means matches exactly one character. These are the common like patterns. One more thing. Like is case sensitive by default. If you want case insensitive, use I like instead. 9. Error handling. What is error handling? Error handling lets you show custom pages when something goes wrong, such as 404 not found. Also, instead of showing the default Flask error screen, you can show a nice user-friendly page. Let's say you want to create your original error pages for 404 not found errors. As shown here, you can use the error handler decorator to handle specific HTTP errors, which means whenever a user tries to visit a page that doesn't exist, run the function page not found. The error parameter contains information about what caused the error. Then Flask will show the 404 HTML template located in your templates folder. Let's see how it works. When the user visits a page that doesn't exist, Flask shows the custom 404 page like this instead of the default error message. You can customize the message layout and design inside the 404 HTML. Next, internal server error 500. It happens when something goes wrong inside your Flask app. The server failed to complete the request because of a bug, crash, or unhandled exception. Here's the example. First, prepare a decorator for handling 500 internal server errors. It tells Flask, if something crashes inside the app, run this function. Next, prepare a route to simulate a crash. This code immediately crashes the app since it causes a zero division error. Flask catches the crash and triggers your custom internal error function. Then you can show your custom 500 HTML page. To see your custom 500 error page in this test, run the app without the debug. Otherwise, Flask will show the developer error page. 10. Demonstration. 1. Overview. In this demo, we will develop a task manager app that includes CRUD operations, form validation, database integration, template rendering, static styling, and more. For example, when you open the app in the browser, you're greeted with a clean title at the top, Task Manager, along with a link that says Add Task. Below that, you see a list of existing tasks, each displayed with a title, a description, and 2 buttons, Edit and Delete. When you click Add Task, you're taken to a form with fields to enter the title and description of a new task. After filling in the form and clicking Submit, the app saves your input to the database and redirects you back to the home page. A green flash message briefly appears saying something like Task Added Successfully to confirm the action. The new task now appears in the task list with its title and description perfectly aligned with the other tasks. If you click Edit on any task, you are taken to the same form pre-filled with that task's data, allowing you to update it. Submitting the edit updates the task in the database and again shows a success message. Clicking Delete removes a task instantly and takes you back to the main list, clean and updated without the deleted item. This is a simple application, but perfect for reviewing what you've learned so far. Includes building a full web application like this from routing to database integration and styling. Let's learn together little by little. 2. Tech stack. This project uses a simple but powerful set of tools to build a fully functional web application. Operating system. We use macOS, but you can build this project on Windows as well. Programming language. The entire app is written in Python, which is known for being easy to learn and great for web development. Web framework. We used Flask, a lightweight web framework that makes it easy to create web apps quickly. With Flask WTF, we built secure forms. Flask SQL Alchemy lets us interact with our database using Python code instead of raw SQL. Database. All tasks are stored in SQLite, a file-based database that's perfect for small projects. We use DB Browser for SQLite to view and manage data visually. Front end. The interface is built using HTML and CSS with Jinja 2 templates to dynamically display content. Development tools. We used VS Code, but you can use any text editor or IDE you like. 3. Setup. 1. Create a project folder. Follow these steps to set up your project step by step. Okay, let's open your VS Code. Then make a new folder for your Flask project. You can create it anywhere, like your desktop. To open it in VS Code, drag and drop the folder or select Open Folder from the top tab bar. 2. Create virtual environment. This is optional but recommended. Open a new terminal in your VS Code. Run this code in your terminal. A new virtual environment is created here. Next, activate it with this code. You should see something like this appear before your terminal line. So now you're working inside the virtual environment. 3. Install required packages. With your virtual environment activated, install the necessary packages. In this project, Flask, Flask WTF, and Flask SQL Alchemy. You can install them all at once. If you are notified to upgrade pip, run the command shown to upgrade to the latest version like this. 4. Create project files and folders. Let's create all these folders and files that will be used in this project. Here are all the folders and files used in this project. Five. Start Flask server. Let's write this code in your app Python file and start your Flask server. Let's click the Run button at the top right. After running the code, you will see the URL in your terminal. Click the URL with Control or Command key. Then you will see Hello World. Great. Now your Flask application is ready to customize. 4. Create database model. Inside your project folder, open a file called models and add the following code. This part initializes the database object. The task is a table model with unique ID for each task, set primary key. Title is required short string. Description is for optional longer text. This model will be used to store and manage task data. 5. Connect database to app. Open your main Python file and add these code. First, import the DB object from the model's Python file. The second part means use SQLite and save the database file as datadb in your project folder. Then initializes the database with the Flask app. Init app connects the DB object from the model's Python file to the app instance. Now your Flask application and the model we defined are connected. Next, let's generate a database. 6. Create database. Now your Flask application and database model are connected. Now let's generate a database from them. Open your create.db file and write this code. First, import the app and DB objects. Next, set up the Flask app context to access Flask app and the database. Then creates all tables with db create all. Let's run this file. Now you see a database file in the instance folder and the message database created successfully in your terminal. Now your database is ready. Seven, create HTML files. Let's prepare placeholders for HTML. In this project, we will use the same layout across multiple pages, so we can use block and extents. Let's quickly walk through each content. First, layout. This is the base layout that all other pages will extend. It contains shared structure like a head section and basic styling. Block allows each child template to insert a specific content. Then we can avoid repeating the same HTML code in every page. Next, index HTML. This is a home page that lists all tasks. It extends layout HTML and fills the content block. Later, it will display a list of tasks from the database. Next, add task. It's a page for adding new tasks. It will contain a form to input the task title and description. Methods are used with both getToShowForm and postToSubmitForm. Next, edit task. It's a page for editing an existing task. It includes a form with the current task data filled in, so it will be accessed by task ID. 8. Create routes. Let's open your main Python file and prepare all route templates and connect to HTML files. In this project, we need routes for the home page and add, edit, and delete to do CRUD operations. First, index. This is the home page. It displays the list of all tasks. We'll add this later. Next, add. This route will display a form to add a new task and handle the form submission. So we need both get and post. Get shows the form. Post saves the task to the database. Right now, just returns a HTML without form data. Later, it will be updated. Next, edit. It allows users to update an existing task. The int task ID captures the task ID from the URL. Methods are get to show the form with existing data and post to save the changes to the database. For now, it returns a HTML placeholder. Next, delete. It handles deleting a task by its ID. A method is only get, it's a default. It returns an index route. These are just placeholders and ready to be filled in as we progress. 9. Create forms. Let's open your Forms Python file and write this code. First, import libraries. Flask form is a base class from Flask WTF used to create web forms easily. String field is a single line text input for the task title. Text area field is a multi-line text box for optional task description. Submit field is a standard submit button. Data required is a validator to make sure the user doesn't leave the field blank. Then create task form class based on the Flask form class. Title field is required. The user must enter something here. Description field is optional. They can add more details if needed. Submit button lets the user submit the form to save or update a task. Add task and edit task will handle this form later. 10. CRUD operations. First, read. Let's update the block content section in index.html file. First, add a link that points to the route for adding a new task. URL for add task automatically generates the correct URL for the add task route function. In the unordered list section, Jinja2 methods are used. The for loop starts a loop that goes through each task list item. Each task list item includes the task title in bold and its description. Also adds edit and delete links for each task. The task ID passes the task's unique ID to the route. because we must specify which task we want to edit or delete by its ID. Then ends the for block that loops through all tasks. Let's go back to the main Python file and update the home route. First, import the task model from your model's Python file. In your homepage route, fetches all task records from the database using query all. Then passes the list of tasks into the template using the tasks variable. Now homepage can show all tasks, but for now we don't have any data in our database. So let's prepare a dummy data. In your DB browser for SQLite, click on Open Database from the toolbar. Browse to your Flask project folder and select data.db and click Open. Go to the Browse Data tab. You'll now see your table. Let's add new data manually. Click Insert a new record icon and enter values into the title and description fields. Let's add more data. Then save it. Controller Command plus S key. Let's start your Flask server again. Now you'll see those new tasks in your browser. Next, let's add a form. Starts the HTML form element. The method post means the form data will be sent securely to the server when submitted. Form hidden tag adds hidden fields required by Flask WTF like CSRF protection. It helps secure your form from malicious requests. This part displays the label and input field for the title form field. Size 40 sets the input box width, and BR adds a line break between elements. This displays the label and text area for the description field. Rows and cols control the size of the text area. The form submit renders the submit button defined in your task form. Finally ends the form in the content block. Next, update the add task route. First, import redirect and URL for navigating between routes. Also the task form class we created using Flask WTF. This part sets a secret key for CSRF protection used by WT forms. In the add route, create an instance of your task form for use in the template. Then checks if the form was submitted and the required fields are valid, like the title is not empty. This creates a new task object using form data, then adds it to the database session and saves it with commit. After saving, redirects the user to the home page. The last part renders the add task HTML template and passes the form into it. This happens when the page is first loaded, which means get request, and the form is submitted but contains errors. Let's see how it works. Now add task works. Next, edit. As you can see, the form section is exactly the same as in add task HTML. It displays a CSRF protection token, a title input, a description text area, and a submit button. The difference is in usage. The root edit task will pre-fill the form with existing data. Let's see that part next. The edit task fetches the task from the database using the given task ID. It returns a task object with title and description. This creates a form and pre-fills it with data from the task object. The object equals task tells the form to use the current task's values for the form fields. Then checks if the form has been submitted using post and all required fields are valid. If it's okay, updates the task object with the new data from the form. Then saves the changes to the database using commit, and redirects the user back to the home page after updating the task. Let's see how it works. The task name is edited correctly. Next, delete. Let's update the delete route. It uses SQL Alchemy to look up the task with that ID from the database. Task query getID fetches one row or returns none if not found. After that, it marks the task for deletion in the database session. Then executes the deletion, permanently removing the task from the database. After deletion, redirects the user to the home page to view the updated task list. Let's see how it works. The selected task is removed successfully. 11. Final touches. Let's improve the UI and UX, such as showing success messages for your action by adding Flash message and optimize the design with CSS. First, Flash messages. Open your layout HTML file and add this code. The first line creates a temporary variable called messages. It stores any messages added using Flask's Flash function. GetFlashMessages retrieves all messages stored for this request. The ifMessages checks if there are any messages. If there are no messages, nothing will be displayed. The for loop loops through each message and displays it in its own list item. The MSG will show the actual text of the message. In your main Python code, just add Flash message in each route like this. This will make the message appear the next time a page is rendered using this block like this. Next, styling. We made these changes to improve UI and UX. Let's quickly walk through the detail. First, the body now has consistent padding, a clean sans serif font, and a light background color to improve readability and spacing across the entire page. Headings, H1, H2, use a dark navy color to visually distinguish section titles from the body text. All links are styled with a clean blue color, and they now only show an underline when hovered, making the interface cleaner and more modern. The unordered list has had its default bullets and padding removed to allow for a custom layout of tasks. Each task item uses CSS Grid to neatly align the title, description, and action buttons into 3 columns, ensuring consistent alignment regardless of content length. The task title is bold and set to wrap cleanly, so long titles don't break the layout. The task description is styled with a softer gray and also wraps properly, making the information easier to scan. The action links, such as edit and delete, are spaced apart and retain the same blue styling to match the rest of the interface. The form element has extra padding and a max width to keep it comfortably readable, with rounded corners for a modern look. Text fields and text areas are full width, padded, and styled with consistent borders and font sizes for a smooth, user-friendly experience. The Submit button now has a bright blue background with white text, and it changes to a darker blue when hovered, giving clear visual feedback to users. Flash messages, success alerts, are now styled with a green background, white space, and rounded corners, making them stand out clearly when an action like task added is triggered. Here are the details of the changes to the HTML file. Creates a CSS link and adds a class so we can style each task block using CSS Grid, and all tasks are displayed in aligned columns. And here are the details of the CSS file. And that's it for this demonstration. We covered how to build a simple task manager app using Flask, set up routing, handle forms with Flask WTF, connect to a SQLite database, and display tasks using Jinja 2 templates and CSS. You've now seen the full cycle of creating, updating, and deleting tasks in a real web application. And that's it for today's video on Flask. We covered the core concepts you need to start building with this lightweight Python framework. Let's quickly review all the learnings. 1. What is Flask? We learned that Flask is a simple yet powerful framework that allows you to build backend web applications using Python. 2. Setup. We learned how to install Flask using pip and how to start building your app with a basic configuration. 3. Basic structure. We explored how to import Flask, create an app instance, define a route using decorators, and run the app. 4. HTTP methods. We used get and post methods to receive and handle data from user input through web forms. 5. Templates with Jinja 2. We practiced using Jinja 2 syntax like double curly braces to inject data, loop through content, use conditions, and organize templates. 6. Static files. We included external files like CSS, JavaScript, and images by placing them in the static folder and linking them using URL for function. 7. Flask forms. Learned how to use WT forms to define Python-based forms, validate input with validators, and render them using Jinja 2 and HTML. 8. Flask with databases. Connected a SQLite database using Flask SQL Alchemy, created models, and performed CRUD operations. 9. Error handling. Defined custom error handlers to provide better user feedback when something goes wrong. And finally, we developed a simple web application using what we learned in this lesson. Flask is a fantastic starting point for backend development, and now you have the tools to create your own web apps from scratch. Don't hesitate to experiment with what you've learned today. Try building a small project like a personal blog or a guest book to reinforce your understanding and gain confidence. Okay, thanks for watching today's lesson on Coding Fab. I hope you found these tips useful and feel more confident. Remember, practice makes perfect, so try using these tips in your project. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and subscribe for more Fab coding lessons. Until next time, keep practicing and stay Fab.